Okay, so when we talk about sinusoidal functions, we're going to start by first understanding the measure of angles. We've always in the past talked about degrees. We're going to switch our brain over to talking about angles in radians. It's a new measurement for you. So degrees, we know degrees. Like we know in our head, what does a 90-degree angle look like, right? What is 180? What is 360? We know those kinds of numbers. So this radian is new to you. Okay, so this is what a radian is. A radian is considered 1 radian once the amount of exterior, which is called the arc, okay, once that distance is the same as the radius, then that's the 1 radian measurement. So where the radius length equals the arc length, so that's what's going on in the summary. If the radius length and the arc length are the same, okay, now that means we've traveled through 1 radian. And kind of technically you will have known this from some kind of past experience, but you just didn't know what you were doing. You've seen this formula before. So in the past, 2 pi r, you've seen that somewhere, like in junior high, right? Does that look familiar? It's the circumference of a circle. The distance around a whole circle is 2 pi radius. And so now we know that 2 pi radius is kind of the same as talking about 2 pi radians. So how many degrees are in a full circle? When you go around a whole circle, when I say degrees, how much is that? 360. So a whole circle is 360 degrees, and now if I do the circumference, that's the total arc length, so the whole circle arc length, which is 2 pi. Okay, as a number-ish sense, 2 pi is 6.28-ish. So I'm just going to go like this, approximately equal to 6.28-ish. Okay, so that's crazy to think about. There's 360 degrees, which is a lot in a circle, but there's only 6.28 radians. So look at how completely different those measurements are. Okay, here we go. Actually, let's change something here. Are you okay for me to make a universal conversion here? If I take both sides and I divide them by 2, I'm going to take this and I'm going to divide them both by 2. This is 180 and this is pi. I just took that understanding and I divided them by 2, both sides. This is going to be our universal conversion. Okay. Convert to radians and draw. Okay, so 90 degrees equals how many radians? When I know that 180 degrees is pi radians. So we just learned that. So what I've set up for you is just a ratio, a proportion. How do you solve something in math that looks like that? What's a good strategy for that? Anybody know how to do that as a strategy in math? Cross multiply? Have you done something like that? So I'm going to multiply. Does that look familiar when you cross multiply? Multiply like that, and then you divide by that. So you can be in your calculator. So I'm getting 1.57 as an answer.
Do we write equals or approximate?
You can just write equals for that. Yeah. It is rounded, obviously, but when you, in this course, if you're doing final answers, you can round them to 2 decimals. Okay, I'm not sure if your books and your papers will ever do this, but this is what I also did. I times, right? I did 90 and I times it by pi, and then I divided it by 180, right? That's what you told me to do, to times, cross multiply, and then divide by 180. Does anybody know what to do in math with that 90 and that 180 in a fraction like that? What could you do? You could reduce, right? You could cancel 90. So if I canceled 90, this would go away as a 1. And if I divide this by 90, this would be 2. So then it's just a half of a pi. Okay? Which is the same as 1.57. Pi divided by 2. But I'm just not sure if your book and your papers will have that kind of language. So that's where it's coming from. Okay, 45 degrees. Oh, we have to draw that 90-degree angle. So how do you draw a 90-degree angle? There's a 90-degree angle. It's at the top. Let me see here. Yes, I have to tell you, because some of you, Jacob, when we were just in applied, because you didn't take pre-calc, did we ever do angle talk like that, starting with angles? Do you remember that? No, okay. So when you're drawing an angle, this is where you always start from. It's not like a clock. It's weird. Clocks start at the top. We're not doing that. We start here, right? So this is like a 90 degrees of travel. This is 180 degrees of travel. So those of you that had pre-calc would know this, but if you were just in applied last year, you wouldn't see this. Now if I travel here, 270, and now I've traveled 360. So that's when we do angle talk, that's always the original. Start, okay? If you ever see a negative angle, it means instead of traveling upward from there, you just travel downward. Okay, 45 degrees. So I'm going to go 45 degrees equals how many radians? When I know 180 degrees is a pi. Okay, so as a decimal, I'm getting 0.79. That's how many radians. And like I said, it's going to seem really small because we're taking that 360 in a whole circle and it's 6.28. That's quite a bit of a difference. So 0.79 radians. And if I'm to think about it like this, you might see this again. So again, we times it by pi and we divided it by 180. And if somebody was doing it like this, they might see I can reduce, this is divisible by 45. So 180 divided by 45 is 4. Okay, and that makes sense to me because 180 is pi, 90 is up here if I cut it in half. 45 is when I cut it into quarters. And if I draw 45 degrees, it would be right in the middle there. Okay, 150 degrees equals what? When you know that 180 is a pi. Cross multiply. Okay, 2.62. And if I'm going to draw that 150 degrees, we would be over there. And how did I kind of think about that? Well, I knew 180 was there. 150 is 30 degrees less than going there. Okay, let's do 2 more here. So again, it's the same method. We're set up our ratio, so we're going to cross multiply to solve that. Before I'm typing this, 450 is bigger than 360. So I already in my head know it's going to be bigger than 6.28. Does that make sense to you? Can I show you something in your calculator? So before I'd already typed in 150. I typed this, 150 times pi divided by 180. I just want to get that back so I can be lazy and not type it again. Did you know that you can bring stuff back on your screen by pushing second enter? And the last thing I typed is on there, and now I can be lazy and just change 450. Okay, so that's just a little trick on your calculator if you're typing stuff and want to not enter it again. So we knew it was bigger than 6.28. So that makes sense. Okay, how do we draw that? How do we draw that? Okay, so what I'm going to do here is ask myself, after 360, how much more do I have to go? So 450 minus 360 means 90 extra. So that means I went like this. I spun around the circle once, then I moved 90 degrees more. So think about yourself, your body spinning in a circle. Okay, some of you might be skateboarders or snowboarders, whatever. Like that's how you're spinning in a circle. Okay, 690. Let's actually draw this one first. So 690 is way more than a full circle. So how much more than a circle is it? 330 more. So let's draw that. A full circle and then 330 degrees more. Okay, so do we have a guess on the number before we even try it? My guess is like 12-ish because 6.28 and then it's almost doubled that. So let's see what we can come up with. So times and divide is always what we're doing. Ooh, I had a pretty good guess here. 12.04 is what it came out to be. Okay. Last question about this. Which is bigger, 3 pi or 8 radians? You can draw each, convert to degrees if you want. I'm going to do this without converting and then we'll do it with converting. So 3 pi, I'm going to travel for 3 pi's. So again, how much is a pi exactly equal to? 1 pi is what? 180, right? So how do you travel 180, another 180, and another 180? Can you think about doing that? So this person will have to travel 180, 1, 2 pi's, 3 pi's. That's how much spinning they would do. Okay, 8 radians. I know that this is 6.28. And I knew that 90, going another 90 was 1.57. So I think I'm going to be going a little past that. So with that, who spun more? 3 pi would have done more spinning. Okay? So that would have been me doing everything with radians. Now, if your brain's saying, I just have no idea how to draw a radian, you can always convert to degrees, because degrees is more of your brain's language. So how do I convert that? So we're going to do kind of the opposite of what we just did. So 3 pi equals what when we know pi equals 180? Do you see how I just lined them up different in my ratio? Because you always have to have the radian stuff lining up with the degrees. Okay, so when you're doing ratios, you always have to have the same t-shirt and pants partners. Okay, times, divide. If you times and divide that, what do you get as an actual degree? 540 degrees. So then I would do how much after 360? 360 plus another 180. So that's what we drew. We did 360 and then we did another 180. Okay, on this one, 8 radians is how much degrees? And again, set up your ratio, radians with radians, degrees with degrees. So 1 pi radian equals 180 degrees. I can times and divide. Okay, so when I draw that 458 degree angle, I have to think how much past 360 should we go? 360 plus 98 degrees more when I'm drawing it. So 360 plus 98 more. 360 plus 98 more. I went past that. Okay, so you can think about which one is bigger now. Now you can clearly see because this is 540 is way bigger than that.